All right, I'd like to continue this lecture with an in-depth look at the graphs of sine, cosine, and tangent. One thing you'll notice about these graphs is we often do them in radians along the x-axis. Just helps prevent us from writing a lot of numbers down here that could really get jumbled together. And radians are convenient because we hit all of our key values at specific radian measurements. So yeah, this worksheet's available on my website if you want to print it off, although I think you can do a pretty good job just in your notes if you're pretty neat. And if you've got some graph paper, you don't have to print it off. It's just there if you want it. Okay, so let's start with just this table down here. I want to get all of the sine values and a decimal approximation for them between 0 and pi over 2. So I'm going to really hone in on this interval here, and then I'm going to use some symmetry to fill in the rest of my points. So create this table, and now I want to draw each of these angles. So I want a triangle with a 0 degree angle, so that's our flat triangle. So that's a 1, 1, 0 triangle. Pi over 6, well that's 30 degrees, so I want to do a 30, 60, 90. And then I get 1, 2 in the square root of 3. Pi over 4, that's a 45 degrees, so I'm going to do a 45 degree triangle with side lengths 1, 1 in the square root of 2. This is pi over 3 is 60 degrees, so it's like this triangle flipped around. So 60 degrees, the steeper angle on the bottom left here. And then it gets lengths 1, 2 in the square root of 3. And then pi over 2, well that is our straight up and down triangle with side lengths 0, 1, and 1. All right, so opposite of our hypotenuse for all of these. These are all we got to do is find all of the opposite of our hypotenuses for all of our special triangles. So starting with 0, opposite of our hypotenuse is 0 over 1, that's 0. Opposite of our hypotenuse for this is 1 over 2, so 0.5. Maybe down below I'll write the actual fraction, 1 over 2. All right, opposite of our hypotenuse here, 1 over root 2. And I just want a decimal for that. So I'm just going to do on my calculator 1 divided by the square root of 2 is 0.71. To be more precise. Opposite, square root of 3 over 2. 4 pi over 3, and I'm just going to do that in my calculator. Square root of 3 divided by 2, I get 0.86. Maybe this rounds up to 0.87. And then opposite of our hypotenuse would be 1 over 1, which just equals 1. This is 0 over 1 down here. All right, so here's the exact values, but I just wanted the decimals this time so that I can plot them on this graph here. I'm going to go from 0 along the axis all the way up to 1. So each of these boxes is a fourth of a unit. The sine wave starts at 0, so it has a point at the origin. Then pi over 6, well this is pi over 4 here, so it's a little bit on the inside of this line here. We're up at 0.5. So about 2/3 of a box over and a half of a unit up, or 2 boxes up. Then at this little hash mark here is pi over 4. We want to be up at 0.71, so this is 0.75, so just a little bit below, right along this line and just a little bit below that line there. All right, then pi over 3 is another third of a unit past this. We're up at 0.87, so that's 0.75, about halfway. So a third of a box over, about half of a box up. And then at pi over 2, we're up at 1. And so that is the curve of our sine wave there. We can connect that up. Now to make this curved line. And now the thing about sine waves is that they're periodic. So we're going to repeat this pattern coming back down. So we're going to be symmetrical over the line pi over 2. This point over here is going to be symmetrical to this one over here. This point here is symmetrical to this point here. This point here will be symmetrical to this point here. And by the time we reach pi, we're back down at our x-axis. So that is our super detailed first arc of the sine wave. All right, and then it continues to be symmetrical. So all of this structure here is repeated, but on the negative side over here. So this point here is about 2/3 up, and then 2 boxes down gets reflected down to this point here. This point gets reflected here. This point gets reflected here. Another point there. Point, point, point. And then at 2 pi, we're back to 0. All right. And that right there is a full cycle of the sine wave. All right, let's keep this going over this direction. I'm going to skip these like partial units and just do the 0.71 and the 1. So I go 1 box back, I go 0.71 down, then 2 boxes, I'm down to -1, 0.71 back to 0, 0.71, 1, 0.71 back to 0. And there is our sine wave. All right, and as we keep going, it just continues to oscillate like this back and forth every 2 pi units. Okay, so what is the amplitude of this? Well, the midline is right along the x-axis, and then it goes up to a maximum of 1, so the amplitude is 1. The period, how far do I have to travel on the x-axis to make a full cycle? Well, just coming back to here is not a full cycle. We need to get the negative part too, so that this whole structure is repeated. So it's 2 pi for a period. Starting value, so when x is 0, sine is 0. The max it reaches is 1, the minimum is -1. The midline is the equation y equals 0. Domain is all real numbers. And the range is -1 is less than or equal to y is less than or equal to 1. We oscillate between those two extremes. All right, let's try this with cosine, just a little bit quicker now. So draw all of my special triangles. So I can get the adjacent over hypotenuse. Here for this flat triangle, the adjacent is 1, the hypotenuse is 1, so this is 1, from 1 over 1. For our 30, 60, 90, our adjacent would be square root of 3, our hypotenuse is 2, so root 3 over 2, which we saw was 0.87. All right, with the 45, 45, 90, adjacent is 1. Hypotenuse is root 2, so 1 over root 2, which we saw was 0.71. At pi over 3, adjacent is 1. Hypotenuse is 2, so 1 over 2 gets us 0.5. And then at 90 degrees, our adjacent is 0, our hypotenuse is 1, so 0 over 1 gets us 0. You notice it's very similar to sine, but just in reverse. So cosine does kind of the reverse pattern through that first interval there that sine does. All right, let's graph this. So at 0, we're up at 1. All right, 2/3 of a unit over, we're at 0.875, so we've come down about half a box, we're going over 2/3 of a box. Then 0.71, so just a little bit below there. Then 0.5. And then at pi over 2, we're down to 0. So there is the initial arc of a cosine wave. And then it repeats. It goes down to the negatives next because it wants to keep a nice smooth arc. It's never going to make like a sharp corner and then bounce back up. So it continues on down here, hits negative 0.5, negative 0.71, negative 0.87, and then negative 1 by the time we reach pi. And then that repeats again. See, this one just looks a little bit off. All right, and then repeats on the way back up. So at a little bit short of the line, we've got a point, then 0.71, 0.86, and then we're back up. And at this point, we can connect this back over here. We have formed a full cycle of our cosine wave. All right, and it continues going back this direction. 0.71, 0, negative 0.71, negative 1, negative 0.71, 0, 0.71, 1. And there is a very detailed cosine wave. You might notice, pretty darn similar to our sine wave, but just shifted over. All right, amplitude is 1. Period, 2 pi. All right, it takes the same amount of time to repeat, it just started at a different value. Starting value of 1, maximum of 1, minimum of negative 1. Midline is the same, y equals 0. Domain and range are the same, all real numbers. And negative 1 is less than or equal to y is less than or equal to 1 for range. All right, tangents where it gets a little bit weird. It's not going to follow that same wave because we've already seen earlier that tangent has these undefined values. Those are going to be represented by vertical asymptotes. Okay, so tangent is opposite over adjacent. Draw our special triangles. So this is the 0, 1, 1. So opposite is 0, adjacent is 1, 0 over 1, at 0, tangent is at 0. All right, our 30, 60, 90, so 1, 2 in the square root of 3. Opposite over adjacent is 1 over root 3. Plug this into my calculator, 1 divided by the square root of 3. Is 0.58. Okay, a little bit different. Pi over 4, so that's our 45, 45, 90. Opposite over adjacent is going to be 1 over 1, which is just 1. 60 degrees. Now the 1 is moved here. Square root of 3 is here, 2 is there. Opposite over adjacent is square root of 3 over 1, which is just square root of 3, which is approximately 1.73. And then at pi over 2, we've got our flat triangle facing up like this. Opposite is 1, adjacent is 0. Hypotenuse is 1. Opposite over adjacent is 1 over 0. This is undefined. I didn't write that right. Undefined. All right. So let's plot these. For 1, I want to go now 1, 2, 3, 4 on my y-axis, because I can see I get higher than 1 with the tangent wave. Okay, so what it's going to do is at 0, we're at 0. At 30 degrees, we're at 0.58, so 2/3 of a box over, about a half box up. At pi over 4, we're at 1. And then at pi over 3, we're at 1.73. And then at pi over 2, we're undefined. And that's going to be a vertical dotted line. I need that to be dotted. So here's our tangent wave. It starts at 0 with an inflection point, and then it's got a vertical asymptote in its way, so it has to quickly get up and over that vertical asymptote. And at this point here, it kind of spikes off to infinity. All right, whenever you go up to positive infinity, you disappear and reappear at negative infinity, and then this pattern repeats but reflected down here. So about 2/3 of a box over, we're going to go down 1.7, and then at this point right here at what is that, 3 pi over 4 comma -1, and then this point here gets reflected right about there, and then we're back to 0. And that is a full cycle of the tangent wave. There. And then this whole thing repeats. I'm just going to copy down every pi over 4, we're going to go up another unit. So it kind of loops like this, and then we've got another vertical asymptote in our way. So at 3 pi over 2, we've got another one of these dotted lines. We've got to get over. There's a vertical asymptote at negative pi over 2 and negative 3 pi over 2. And here is our tangent wave fitting in there. Okay, so in this interval, sometimes it's good to just do the -1, 0, 1. So you get this kind of diagonal. But you know it's not connected like a diagonal, it kind of curves through there. Let me get a few more points here. All right, and then it's this repeating pattern here. So yeah, tangent, very different than sine and cosine. It has all of these asymptotes that has to keep getting over, and that changes things. Amplitude is infinity now. The period is only pi. This repeats every pi units. Starting value 0, max, infinity, minimum, negative infinity. Midline, still y equals 0 for that one. All right, domain, this is really tricky to write. So it's all real numbers except for those asymptotes. We need to write an equation for when we're going to be right on those asymptotes. And so what we can say is, first we'll just say x cannot equal pi over 2. No, wait, that's not where it is. Yeah, it is pi over 2. Yeah, pi over 2, comma 3 pi over 2, comma 5 pi over 2, comma 2n plus 1 pi over 2. So we can see it's odd multiples of pi over 2. So this gives us an odd number, 2n plus 1 pi over 2, where n here is an integer. N is any integer. Okay, this is, don't worry too much about this right now. This is going to be a big thing. Next unit is writing out when functions are not defined. right now you can just copy this down for tangent. The range, though, is y equals all real numbers, because this does travel from negative infinity to positive infinity. I'll write it like that. Y equals all real numbers. And it doesn't have any exclusions. It goes smooth arc all the way from negative infinity to positive infinity. All right. So that's that for all of these detailed graphs. We'll learn more about how to change them around later on. All right. Have a great rest of your day.